Hello and welcome to this video where we will go through the solutions to the second exercise on our second assignment in our course Competition, Policy and Strategy. This second exercise is on the topics of Cournot competition, so we will for the first time have a look at an actual model in which we can show the strategic behavior of oligopolistic firms. Alright, in this exercise we are faced with a situation where there are two firms in a market, and we know that by assumption this market is characterized by Cournot competition. We further know that the demand is defined as a function Q of P, so quantity as a function of the price equals 20 minus P. And then finally we know that the marginal costs of both firms are constant at lower C equal 20. Alright, now let's dive into the exercise itself. In the first step, we are actually not looking at the model itself and at the solution of the model itself, but rather let's take a step back and have a look at what it actually means when we are talking about Cournot competition and how it compares to situations which we know from the previous assignment, namely perfect competition as well as monopoly. So the two models which we have already considered in the first week, in the first assignment of this course. Alright, so there's of course a lot of things to say about the differences between Cournot competition and perfect competition and monopoly on the other hand. So one way to systemize our answer is to look at the differences with regard to four different dimensions in which we can compare these different models. The first dimension in which we want to discuss the differences between these models is the number of firms in the market. And of course, from last week, we already know these first two statements. The first one is that in perfect competition, the number of firms is very high. Last week we were referring to this situation as an atomistic market structure, which of course means that there's a lot of individually small firms, right? Then last week we already identified that monopoly kind of is the opposite of the spectrum, which means in this case in monopoly there is the absolute minimum amount of firms possible, namely one single firm. And now this week we are looking at oligopolies, and Cournot competition is one way to model an oligopolistic market, which of course means that in this situation we are somewhere in between these two extreme cases that we already know from previous week. So in Cournot competition we are typically talking about relatively few firms. So that of course means we need to have at least two firms, and typically we're using these kind of models when we are looking at a few firms. Let it be 2, 3, maybe 5. In very rare cases it's actually substantially more than 5 or 6 firms in the market. Of course you can include even more firms. The model does not permit it, the model does permit it, but typically we are looking at relatively few firms. In general, what we see, why does the number of firms matter? Well, in general, we see that the more firms there are in a market, the lower will the prices, the equilibrium prices be, of course, ceteris paribus. And of course, if we see lower prices for a decreasing demand function, this implies larger quantities, right? So that's just how this number of firms influences the market outcomes, in general speaking. The second dimension we want to have a look at is the type of goods. Last week we already discussed that in order to model perfect competition, we need to assume that we have homogeneous goods. And last week we also said that this translates to a situation where the consumer really does not care from what firm they buy their good, because you cannot differentiate between the goods. They are all homogeneous from the perspective of the consumer at least. When it comes to monopoly, of course, I mean, there's only one single firm, and if this firm only offers one single product, then it does not really make sense to talk about product differentiation in a single product market, right? But of course, we can consider situations where there's one single firm, so a monopolist, offering several goods that are in some way or another related to another. So we can have models with differentiated goods in a monopoly. That's totally fine. Yeah, we can absolutely consider this and model this. So the monopoly, saying that we are looking at a monopoly, really does not tell us a whole lot about the kind of goods we are looking at. And the very same thing is true when it comes to Cournot competition. Similar to what we can do in the monopoly, we can model a Cournot competition for homogeneous goods as well as for heterogeneous goods or differentiated goods, right? So just by knowing that this is a Cournot competition does not tell anything about the kind of goods and how they relate to another. So in general, why is this important, the type of good? In general, we see, so again, I want to emphasize the in general part of this answer, because it really depends on the specific model. But in general, we will see that differentiated goods result in higher prices and higher profit margins. All right, the third dimension in which we want to characterize or lay out the differences between these three types of models that we know so far is the strategic behavior aspect. Again, last week we already identified that in perfect competition, each individual firm cannot influence the market outcome whatsoever. So what we can say, or another way of phrasing this, is that all firms are price takers, or that all firms adjust their quantities according to the price they observe in the market. They cannot influence the price, the equilibrium price, or the total equilibrium quantity in the market at all. In contrast, so again, like the exact other extreme end of the spectrum would be the monopoly, where the monopolist chooses either the price or the quantity, and thereby defines the respective other, right? Considering a demand function which links prices and quantities that are demanded in the market, the monopolist can choose either one, and the other one, of course, depends on the specification of the demand function. But again, the monopolist is the one who chooses the market price and chooses the market quantity thereby. And then finally, in this now new model, the Cournot competition, what we will see is that the output quantity is the strategic variable. That means that firms, by assumption, maximize their profits by choosing the profit maximizing output quantity. All right, and the price then just happens on the market. All right, now to the fourth dimension, information and barriers to entry. Again, we already discussed last week the perfect competition example, and we already discussed about, or we already thought about perfect competition in the long run, where we specifically allow for market entry, etc. So we already know that in the perfect competition setting, we have complete information. There is no asymmetries in information between firms, and there is no barriers to entry or to exit the market. In the monopoly, well, it really depends on the specification. We can have a look at a monopoly with or without barriers to entry. And the results, of course, of these models, the implications of these models will depend on what we assume. So in general, both is possible. So both asymmetric information as well as barriers to entry are possible to think of in the model of a monopolist, and at the same time both asymmetric information as well as barriers to entry are even possible causes of monopolies. And we will talk about barriers to entry specifically as a cause of monopoly in a lecture and exercise session during this semester in a few weeks from now. Then finally, again, the new kind of model that we are only getting to learn today, the Cournot competition. Well, in this case, again, it really depends on the specification. We can have a look at a model with or without asymmetric information, and we can have a look at models with and without barriers to entry. So it really depends on the specification of the model. In general, again, why is it important to consider these aspects, information and barriers to entry at all? Well, what we in general, again, can observe is that if we include asymmetric information or if we include barriers to entry, we can get market results, equilibrium results, where we have a price that is larger than the marginal costs or that increases the price to cost margin above a benchmark situation. All right. So in general, information asymmetries and barriers to entry can be drivers of increased profit margins. All right. With that, there's only one final slide on this task A, and that is on the additional assumptions of the standard in quotation marks, because that's not really like a generally accepted term, I guess, but the most simple Cournot model. So this is really, when it comes to Cournot modeling, to analyzing a Cournot model, this is basically the benchmark situation, the baseline situation, where there is which we will usually compare market outcomes against. All right. So this refers to the most simple Cournot model in the sense that we abstract in this baseline model, in this most simple version of the model, we abstract from cost asymmetries. So all firms have symmetric costs or identical cost functions. Furthermore, we usually, or in this most simple Cournot model, we consider a linear inverse demand function, similar to what we already did when it came to, or when we were analyzing the monopoly and perfect competition in the previous week's exercises. We also usually, in this very most simple Cournot model, assume a situation where we have a simultaneous game, meaning all firms make their strategic decision at the same time, or without knowing what the other firms will choose as their strategic variable. And then finally, we will, in this most simple Cournot model, assume it's a one-shot game, so that meaning that there's only one single observation period, right? Firms choose their quantity, the market equilibrium materializes, and then the whole market is over. Okay, so one-shot game, no uncertainty and information asymmetry regarding demand functions or the cost of all firms. So this slide really shows that we are simply making this Cournot model, which we are just building a very simple Cournot model in which we will assume away everything that might make our calculations the slightest, even more complicated, even in the slightest way. All right. So we are just for every of these bullet points, you can consider an alternative model where we simply drop the respective assumption, and you will see that the outcome changes and that the model will become ever so slightly more sophisticated and complicated and can accommodate for maybe a little more realism, right? So that's enough on this standard Cournot competition. And again, standard, it's not really a standard in the sense that everybody in the literature is assuming all of these or taking all of these assumptions, but rather during this course on competition policy and strategy, when we are talking about Cournot competition without any further assumptions, this is the world that we are looking at. All right. And with that out of the way, let's actually have a look at the market result in a Cournot competition, in the very most simple standard Cournot competition. So we are now in the first step asked to derive the reaction function for each firm and to illustrate them graphically. So the first step towards finding the market equilibrium. How do we find the reaction functions? Well, the reaction function is conceptually the best response of a firm regarding the strategic choice of all other firms. All right? The strategic variable, so the variable a firm can choose in order to to maximize their profits, of course, is quantity in a Cournot model, right? So, and quantity is the strategic variable of every single firm in the Cournot model. So what this reaction means is we are looking for a function that gives us the profit maximizing quantity for firm I as a function of the quantity of all other firms, and for simplicity, let's just consider there's two firms, so the single other firm. All right, that is what we are looking for when we are talking about the reaction function. Keeping in mind that this basically is looking for the best response, a function that always provides the best response. Now, how do we find this best response? Well, we are looking for a function that gives us the profit maximizing quantity of a firm I. All right, so the starting point would be to find the profit function and to calculate a maximum of this profit function, right? So let's start with the demand function, and from this demand function stating the profit function, using this demand function stating the profit function. So of course the profit function basically reads P minus C times QI, right? That is the profit function, the price minus the marginal costs multiplied with the respective quantity of the firm whose profits we are calculating right now. Okay, so we simply substituted P, we substituted C for their respective values, and QI simply the output quantity of firm I. What we will have to keep in mind in this step is, of course, that Q, so the total market quantity, is calculated as the sum of all individually produced quantities. So Q, the uppercase Q, the total market quantity, is calculated as the sum of the individually produced quantity QI of firm I, or in this case firm 1, plus the individually produced quantity of firm 2, namely Q2. All right, so this is how we find the profit function. Now, as I have laid out earlier, we now need to find the profit maximum based on this profit function. And again, because we are in the Cournot competition, by assumption, the profit maximizing strategic variable is the quantity. So the firm, or all firms, are maximizing their respective profits by choosing the output quantity. We are maximizing pi 1 as a function of Q1 and Q2 over the choice of Q1. Okay, this of course yields a first order condition for the maximum, which is written down in the third line on the slide, which reads 200 minus 2 times Q1 minus Q2 minus 20, which all must equal 0 in order for this first order condition to hold. We can then solve this expression, this first order condition, for Q1. Again, keeping in mind that what we are looking for is a function that provides the profit maximizing quantity of firm 1 as a function of all other model parameters. In this specific case, all other model parameters is simply the quantity Q2. Okay, So what we have calculated here is a function q1, of q2, which equals some expression. All right? So what do we have now? It's of course a reaction function. Okay? It is giving us the best response of firm 1 considering the strategic choice of firm 2. Okay. That is why, from this second to last to the last step, that's of course simply rearranging the expression. Dividing 180 by 2 yields 90. So we have q1 equals 90 minus q2 divided by 2. And this now is defined as R1 of q2, R1 meaning reaction function of firm 1. All right? We can of course call this q1 of q2 as well. This is just a matter of naming convention. Okay, so now we have found the reaction function of firm 1. Or again, just to reiterate, we have found a function that provides the profit maximizing quantity for firm 1 for any quantity that is put out onto the market by firm 2. Okay, so we know the best response for firm 1. We know the reaction function for firm 1. We now, of course, in order to find the market equilibrium, need the reaction function or the best response for firm 2 as well. So in general, we would have to do the exact same procedure, but for firm 2 now. So we would have to state the profit function for firm 2, find the profit maximizing quantity of firm 2, etc. Solve it, all the things that we just did. Luckily, in this specific case, both firms are symmetric, meaning both firms are facing the same demand function, they have the same cost function, so overall their profit function is the same as well. Okay? And knowing that we have symmetric firms and thereby the same profit function, etc., we can simply we know that the reaction function of firm 2 will look exactly the same as the reaction function of firm 1. Okay? Just of course with the indices switched around. Okay? So if the reaction function of firm 1 reads R1 of Q2 equals 90 minus Q2 divided by 2, then the reaction function of firm 2 reads 90 minus Q1 divided by 2. All right? So by symmetry of the firm, we can simply state that this is the reaction function of the second firm without having to do all the calculations once over again. All right, now the final step towards finding the market equilibrium. I already hinted earlier that once we know the best responses or the reaction functions of the firms, we can find the market equilibrium by finding conceptually the one point where both firms are playing their best response onto the best response of the other firm. All right, so the best response on the best response. That, mathematically speaking or analytically speaking, means we are looking for the intersection of the reaction functions. Because in this intersection, it is true that, in this one single intersection, it is true that both firms are choosing their profit maximizing quantity at the same time. All right, how do we find the intersection of two functions? Well, it's rather simple. We can simply substitute, for example, for Q2. So we know that the reaction function of firm 1 was Q1 equals some expression that depends on Q2. And now for this Q2, we plug in the profit maximizing quantity Q2 as a function of Q1, so the reaction function of firm 2. All right, so this Q2 equals some expression is now substituted into the reaction function of firm 1. All this is happening in this step down here. And what we are faced with now is a function Q1 that only depends on Q1. There is no Q2 in it anymore. It reads Q1 equals 90 minus 1/2 times, and now of course the reaction function of firm 2, which reads 90 minus Q1 divided by 2. So we have an expression that only depends, or that only contains a single variable. So of course we can solve for the single variable. And if we do so we just rearrange until there's Q1 on the one hand side and a single number on the other side, then we know that Q1, now with a star because it's the equilibrium quantity of firm 1, equals 60. Okay? So this 60 simply results from solving the intersection of the reaction functions for the one single parameter that still remains in it. Now that we have calculated the profit maximizing and equilibrium quantity of firm 1, we would again in general have to do the exact same for firm 2. So state the reaction function of firm 2, which of course depends on Q1, right? And substitute Q1 into it, so it only depends on Q2. Luckily, again, by symmetry of the firms, because they are facing the same profit function, they both have the same reaction function, everything is the same for both firms with their respective indices, of course. We don't have to go through all of these steps again. We can simply argue by logic that for this symmetric case, Q2 must equal Q1 or Q2 star. The equilibrium quantity of firm 2 must equal Q1 star, so the equilibrium quantity of firm 1, which was 60. So now we have found the equilibrium quantities of both firms. All right. Now, this exercise did not only ask for us to state the reaction function of both firms, but it only asked us to illustrate them graphically, and that's what we did in this plot. So the dark blue or black line is the reaction function of firm 2, so it's the quantity of firm 2 as a function of Q1. All right. So what you can read is for any quantity Q1 on the horizontal axis, this dark function provides the profit maximizing quantity of firm 2. For any possible quantity or feasible quantity that firm 1 can produce, this function provides the profit maximizing response of firm 2. All right? And the only equilibrium in this situation is of course where both firms are playing their best response at the same time, which is in the intersection of these two reaction functions. So in this, as you notice when you're looking at this plot, well, in this intersection, it's true that for this given quantity of Q1 equals 60, this firm 2 will put out a profit maximizing quantity of 60. That's what we know from looking at the reaction function Q2, so the dark blue line. At the same time, now switching to the firm 1's perspective, when we're looking at the orange line, we notice that for a quantity of 60 that is produced by firm 2, it is profit maximizing for firm 1 to also produce 60. Okay? And thereby we have found the market equilibrium in a graphical way. Conceptually, of course, finding the interception is exactly the same as calculating by substituting these functions into another. Okay. Now we are finally asked to derive the firm's profits, consumer surplus, and welfare and market equilibrium. Because again, we have in the previous task already identified what the profit maximizing quantity in the market is. And for a given demand function, we can now, of course, calculate what the resulting price in market equilibrium is. Okay? This is, of course, keeping in mind that the total quantity in the market is the sum of the individual quantities of both firms. Okay, and if both firms are producing 60, then the total quantity in the market for these in the market with these two firms only is 120. And for 120, for a total quantity of 120, this is the price that that results on the market. We can simply find out by plugging this quantity into the demand function, of course. Now, knowing the market quantity, the equilibrium quantity, excuse me, now knowing the equilibrium quantity of each firm and knowing the equilibrium price on the market, we can of course calculate the individual firm's profits as well. We already know this profit function from the very beginning of this exercise, so profits are the market price minus the marginal costs, all in brackets, multiplied with the individual firm's quantity, equilibrium quantity. If we now plug in all the numbers, so we know the market price, the equilibrium price is 80, we know the marginal cost is 20, that was just given in the assignment, of course, and the individually produced equilibrium quantity is 60, well then we can calculate the profits for each individual firm, which is 3,600 in this situation. Okay, now we know the firm profits, so second step or next step would be calculating consumer surplus and welfare in this market equilibrium. Consumer surplus again yields or results as the area below the demand function and above the market equilibrium price. We can calculate it using this integral, integrating the demand function, right? Of course, as we discussed last week already, in this case, as well as in the previous cases we were analyzing, or markets we were analyzing, we again are faced with a linear demand function. So this area below the demand function and above the market price is a triangle, and we can simply calculate the area of the triangle then. Okay. Nonetheless, this formula is generally true and will yield, just like if you were to calculate the area of the triangle, it yields a consumer surplus of 7,200 for, again, all this keeping in mind that the total quantity in the market is the sum of both individually produced quantities. So in total there is 120 units produced and sold on the market. Okay. Then finally, knowing the profits of each individual firms and considering that there's two of them, so we have to, in order to find the total profits in the market, of course, have to multiply the individual profits with the number of firms. Adding this to the consumer surplus, which we just discussed, we can then finally calculate the welfare and equilibrium simply by adding, right, again, adding consumer surplus and the total profits in the market. In this particular case, the total welfare in the market is 14,400. All right, on to the final task of this second exercise in this assignment. We are now asked to drop the assumption that there's two firms in the market. Instead, we are now considering a situation where there's n identical firms in the market. Everything else stays the same. It's only this one single change in the model. We are then asked to find the market equilibrium as a function of the number of firms, and we are then asked to show that the equilibrium price is decreasing in the number of firms, which we then will have to interpret. Let's start with the first part. Let's find the market equilibrium as a function of this unknown number of firms n in the market. In order to solve this answer, we are conducting the very same steps that we conducted earlier for two firms. Only difference being that we have to keep in mind that we don't know the number of firms and have to consider the parameter n instead. Okay? So the starting point is, of course, the exact same as earlier. We have a demand function, and we can use this demand function to state the profit function of each individual firm. Now you see a difference in comparison to what we earlier did. Earlier, we could simply rephrase Q, the total quantity in the market, to be the sum of Q1 and Q2, right? This, of course, is no longer true. Instead, in this situation, we know that the total quantity in the market is the sum of the quantity that firm I produces plus the quantity that all other firms are producing. And we indicate this quantity that all other firms are producing, all other firms but firm I, as Q with an index minus I. Okay? So in this profit function now reads pi I equals, in brackets, 200 minus Qi minus Q minus I, so the quantity of all other firms, minus 20, the constant marginal cost that we know from earlier, all of this in brackets multiplied with the quantity that is produced and sold by firm I. Okay, so the only change so far is that we have to that we no longer can consider Q1 and Q2, but instead we have Qi and Q minus I. And for now we can just stick with this parameter. For now, meaning when we are now finding the reaction function of firm 1. So the profit maximizing quantity given the quantity of all other firms. So the best response, right? So we state the first order condition, which states that the partial derivative of the profit function of firm I with respect to the quantity of firm I needs to equal 0 in order for this quantity to be a maximum, an extremum of this function. Okay? So we calculate the partial derivative, which is again mathematically exactly the same to what we earlier did. It reads 200 minus Q minus I minus 2Qi minus 20 equals 0. And again, doing the same steps that we did in the previous task, we now need to solve this first order condition, this profit maximum condition, for Qi in order to have a proper response function, or reaction function rather. So that's what we are doing in this in this next line. We are simply solving this expression, the first order condition, for Qi. And if we do so, this expression reads reaction function of firm I as a function of Q minus I, so the quantity of all other firms, or in other words, Qi as a function of Q minus I equals 180 minus Q minus I all divided by 2. Okay. Now, in order to find the market equilibrium, we have to think about how we can understand Q minus I. Because, in order to find the market equilibrium, what we previously did was, of course, finding the intersection between the reaction function of the two firms that we had in the market. We cannot do so anymore because we don't know how many firms there are. We cannot substitute all the reaction functions of all the firms if there's n firms. So we now have to think how we can rephrase Q minus I, how we can understand Q minus I in order to solve and find the equilibrium. And what we can use in order to solve is that the firms again are symmetric in the case that we are analyzing. We have assumed that all firms are identical, all firms are facing the same demand function, all firms have the same cost function, just as we did previously for two firms. And knowing this, we can state that the combined quantity of all other firms, so Q minus I, equals n minus 1 times Qi. Alright, so if all firms are equal, if all firms are identical, then of course the total quantity in the market is simply n times the individual quantity. Okay? Because all firms are symmetrical, all firms are producing the same quantity. If we now want to consider one single firm I and have a look at all the other firms separately, then what we can do is we can restate this expression, say the total market quantity, capital Q, equals Qi plus n minus 1 times Qi. Alright, so we have in total still n firms in the market, but now we have we take a look at one of them and we know that the remainder of the quantity equals n minus 1 times qi, okay? Right. Mathematically, of course, it's really easy to convince yourself that this actually must be true, because if you were to rephrase this expression, what is written here is qi plus n times qi minus qi, okay? And now qi and minus qi cancel out, so we are again at this initial expression, okay? So mathematically, I hope this is obvious. I think the maybe at this point the more important part is to conceptually understand what we are doing here, right? We have n symmetrical firms, and now we're considering one firm and putting all the other n minus 1 firms like in a different basket. Okay, so now using this trick we can rephrase q minus I as n minus 1 times qi. It's exactly the same. And this of course means we can once again, by substituting q minus I with the expression that we have just identified, we can once again restate the profit maximizing quantity of of firm I, so the reaction function, as a function of qi and qi only, right? By substituting away q minus I using this expression that we derived by symmetry, we can once again find a profit maximizing quantity that is no longer a function of the quantity of all other firms, but instead we have q1 equals some expression that only contains q1, or qi equals some expression that only contains qi. Okay, again, this expression, of course, we can solve it. There's only one equation. There's qi on both sides. We can solve for qi, and if we do so, what we will find out is that the market equilibrium quantity is qi star equals to 180 divided by n plus 1. Okay, so just as a reminder, so that you understand what's happening here and can solve all the math by on your own, we have substituted in our reaction function Ri, we have substituted q minus I with the expression n minus 1 times qi. And then we have solved this expression for qi. So now we know, using this, we know the market equilibrium in the sense that we have calculated the equilibrium quantity of the individual firm, qi star. Next step then would be to find the rest of the parameters that identify the market equilibrium, namely the equilibrium price, and then of course we can have a look at we could have a look at profits and welfare as well. So how do we find the price in the first step? Well, again, just as a reminder, in this very first bullet point, we know the profit maximizing or the equilibrium quantity that is produced by one single firm, qi star. And using the knowledge I wrote down on the previous slide, so knowing that the total market quantity is exactly equal to n times this individually, by n individual firms produced quantity, lowercase qi, we can simply calculate the total market quantity, capital Q star, by multiplying the individually produced quantity, lowercase qi star, with n, because there's n firms in the market. So this is the total quantity, capital Q star. Using this total quantity in equilibrium in the market as an expression of n, of course, right? It reads n times and then the fraction 180 divided by n plus 1. So we have the total quantity in the market as a function of the number of firms. Using this expression, we can then find the equilibrium price in the market as well. And how do we find the equilibrium price? Basically, as we always do. We have a demand function, and this demand function is linking Q and P, so Q as a function of P, or P as a function of Q, depending on whether we are looking at the demand or the inverse demand function. And we can now simply plug in the market equilibrium quantity, capital Q star, into this demand function, solve for P, and then we know the price, the market price in equilibrium, again as a function of the number of firms. The way we have phrased this price is maybe at first glance not the most obvious. Once you are doing the calculations yourself, you will notice that there's maybe one or two additional steps needed in order to bring it into this particular form, which reads P star, so the equilibrium price, equals 20 plus, and then as a fraction 180 divided by n plus 1. But there is a good reason why we are presenting the equilibrium price in this way. And this good reason is the final part of this question. We are asked to show that the equilibrium price is decreasing in the number of firms. Okay? And if we do so using this expression for the price, so if we first rearrange the price to look like this, it's just easier to show. You can do the very same using whatever expression you find the most beautiful. But this one, as you will see in a minute, has a little tweak to it so that it's maybe even an even nicer result. Or even easier to read and to understand. Okay? Because what is happening to the price, the equilibrium price, as n increases to infinity? Well, n is in the denominator, in the lower part of this fraction, so if this part goes to infinity, then of course this whole fraction goes towards 0. Okay? So all that's left for the price then is 20. 20 plus something that is going towards 0 is in the limit 20. Now, this 20 is a familiar number in the context of this exercise, of course, because 20 is exactly the marginal costs. And that is no coincidence. In this generalized result for the Cournot competition with n firms, we will always see that as n increases, this margin above the marginal costs goes towards 0. Or in other words, as n increases, the price will approach marginal costs from above. So that in the limit, if n takes very large numbers, we will have a result that resembles or is exactly equal to perfect competition. Which of course shouldn't be too surprising because as n approaches infinity, as we have more and more firms, of course each individual firm in relative terms is getting atomistically small. And each firm individually has a lower and smaller strategic impact on the quantity in the market, right? So it's, I guess it's a quite intuitive result, and it's nice to see that it actually materializes once we are looking at the numbers.